design expert software, and they are all ready. And I would request Dr. Sandeep to start the session and give us a hands-on experience. So without wasting much time, let us quickly jump into this hands-on training program on design expert. And here one important point is, we will try to walk through them, but the main emphasis will be on the factorial design, since the other packages, other designs will be dealt with by other resource persons. So we will try to restrict to the factorial design. Okay, thank you. Please have the hands-on session started. I think, yeah, screening is done, right? Thank you.
Thank you, coordinator, Dr. Varun, for again introducing me for this session. And a very good morning to all the participants who have attended and who have taken time for attending this. As I assume that each and every one is a faculty here or a research scholar here, and the ultimate satisfaction for any person or any speaker or any teacher is like if we are able to reach the masses, that is the ultimate satisfaction for us. I hope we are doing our best and giving our the 100% from our side to satisfy or to reach our the goals which we had to set on. So with this, let us start hands-on. Actually, it's a hands-on for full factorial experiments. Yeah. So I don't know actually, because if it's a physical, we have done it physically, then I would know actually, because I could have seen your faces and all, and I could know actually what. If we are giving some good examples or bad examples, I could at least see your faces, and then I can say, I could have got that feedback, right? Virtual feedback, realistic feedback. But yeah, so let us start with the simplest problem, which we already were dealing with, and now you participants will be much more. I don't know how many would have been with this example, but still much more familiar now. Yeah. The simplest example was like what would be, or which one could I select from one of the bikes, which would there was a $1 million question which would give, or which would be actually preferable. So in the yesterday's session we saw that even though 150cc engine is a bigger one, but still it is okay, right? I am not taken. If it was instead of 150, it was 200cc, the scenario would change. But what we have done is we have taken only 100 to 150cc, so two vehicles which are commercially much more viable or much more easy on our pockets. And we wanted to check up how many means which one would be selecting. So yeah, still it is not a complete set of thing what we were looking into, but still there will be some discussions that when I'm riding daily, I'll be riding single only, right? A driver will be only there. Then why shouldn't I take 100cc? Again, it depends on pickup and all these things in the cost on the pocket, right? If I'm okay with some of the things, sometimes we say Pulsar is okay, right? 150cc. So it's a never-ending process. Nothing is ultimately right, but the only comparison was when the conditions change. So when the conditions change, like, or the factors change, the factors when we consider which are affecting on the response, then depending on the conditions, you can say that for my purpose, this bike would be okay. I am not saying that this may be the ultimate. Yesterday we saw that CC of an engine is not much affecting when the conditions were different for us, isn't it? The levels at which we have taken it or mentioned it were completely different. If we consider somewhere other factors also, it may be this thing, right? So again, it depends on how many factors we are selecting. So dear participants, if I'm not considering much of the time, but I want to just brief out once again. As many of you are most probably, if I say that this STTP was also targeted for participants who are new at doing these things, right? So the STTP is a training program. It's not a faculty development program. So it's just a training program where we aimed actually to see that if a newcomer is also there for this session, he should be able to understand actually what should be the progressive way. Then higher end of it, many will give you the examples and they will guide you. But at the lower end, when it comes, it's very difficult to get the inputs. So the basic thing what I wanted to say is, yes, as in the early session also today, we discussed that first thing is you need to know why you're doing DOE. Simply, it is a fancy word, or most of the papers are showing this thing that DOE is there and some beautiful graphs and some ANOVA tables and the contributions of the factor on the responses or the interactions they are showing. That is okay, right? If you want more data and these things, you can do it. But everyone can't do DOE depending on the conditions, but basically. So you need to check, is it fitting? And yesterday, as I told you, right? Yesterday I was in the discussion with the pharmaceutical guy, and he was doing research. And what I was thinking is when I saw the factors and the levels and their effect on the response, then finally ultimately it clicked that there wasn't a requirement of doing DOE in that, and that to RSM. So you don't need to force fit anything. If you think, or with your knowledge, if you think no, this can be done, then only you have to do it. So once that is fine, then you need to fix the levels. As you're looking into the study, some levels will be getting from the literature or from handbooks and all this, or from our experiences. But we need to fix the levels, right? So the levels what we get is for a generalized case. But for our cases, as we are doing researches and the conditions are different for us, excuse me. So we need to fix the levels. So for that, one factor at a time can be done. For fixing the factors, you know that 2-level factorial experiments can be done. So with that, we know, is our factor influencing the response? If it's not influencing, for our case, CC of an engine is not influencing. The F factor, F value was also above 0.05. So that means that I can neglect capacity of an engine with this kind of response, right? What we were studying. So this is the most important thing. Once you have done that, then you can select any design. If you take RSM, it's much better because we'll be having additional points on which it will be looking up into. So much more robust regression equation also you can get there. Okay, so let us start. Just I'll exit the full screen. Yeah, I hope everyone has got the screen, right? Please go on to your design expert and just open it up. Request is because I can't look into once I'm on this screen, I can't go back on the Zoom screen, right? So please, if anyone can voluntarily take some response, or you can say just yes or no, I can go further steps. If anyone is anyone is not coped up with us, then you can say stop us. You can just stop us somewhere. Dear participant, please, if it's a request, as I told you, I can't see how many of you have done it because it's on your screens, and this is a hands-on session. So if I run away, then it will be lagging, right? So please, if everyone has done, you can just raise your hands at least. Yes, how many of you got this? Yes, how many of you didn't get this screen? If someone is there, you can tell us. Or in the chat window also, you can please mention.
Sir, your screen is not shared, sir.
Yeah, sorry. No, it's shared already.
So it's not visible on my screen.
Please check it out. Okay, 1 second. I'll go back.
Sir,
you are sharing this
Yeah, yeah.
PowerPoint or
No, one second, wait, please.
Design
Yeah,
expert. Now
Um,
it is okay, sir.
sorry. Yeah. Thank you, sir. For, so this screen is there, right? So every participant got this screen, right? Hello.
Yes, sir. Yes, sir. Now it's okay, sir.
Yeah. Okay. Thank you. So now I would like to go for new design. If it is already you've done some design, some recent files are there here, then I can open it directly, or else I'll go for a new design. Okay. So with this new design, if you see, these are two-level fractional factorial design. This is the chart I was showing you yesterday. Green, yellow, and red. These things, green, yellow, and red, are actually fractional factorials, and these whites which are there are actually full factorial experiments. So as we were discussing yesterday, if it is like 3 factors or 4 factors at the max, you can go with full factorial experiments. But apart from that, sometimes what happens is you are a very ambitious researcher and you want to know the impact of many factors on the response, but you don't have time, or you don't have money, or you don't have facilities or doing for that many experiments. Then you can go for fractional factorial experiments. So recommended is full factorial when the factors are less, like 2 to the power of 3 factors, or 4 factors. If it is there, it's fine. Otherwise, when it is more number of factors, like 7 factors, yesterday I told you, right, for 128 experiments, you have to do only 8 experiments, like this one. This was red zone. But if you do this kind of if you do the experiments in red zone, you can't interpret the data. That is the biggest problem. So there isn't any need of doing in the red zone. Try to avoid the red zones. No one will recommend. That is only that example what we gave you yesterday was only to show you how you can reduce, at what fraction you can reduce the experiments. That's it. Otherwise, 2 to the power 7, it should be 128 experiments. But instead of that 128 experiments, you are doing in 8 experiments only in this red zone if you are doing it. So that is one way of looking into. So if you want to do full factorial, go with this white lines. This black actually is the one selected. So if I click on it, it is selected. If I click here also, it is selected. So this black one is this one. This is the highest resolution in fractional factorial green. Try to avoid it. And yellow also, if possible, try to avoid it. We don't go actually, because see, now many research papers are there already, which are available, and which actually they say that already that these are the only factors. Like one of the examples we had, the composite and from pin on disk, we know only these factors will be affecting most probably the response. So that is from our experience, from the literature. When we see, that is from our experience that we are looking into. So you don't need to search what are the, if it is an ultimately completely new area where no other researcher has kept his hand into it, then you can consider some of the factors, and then you have to look into on which factors is affecting. Otherwise, if it's a generalized study, like if I say speed, feed, depth of effect of speed, feed, depth of cut on surface roughness, everyone knows that feed is the dominating part in surface roughness. If depth of cut is more, I know cutting forces will increase. So that is already a thing. But there are some factors when, like MQL I am using, where if I say like the pressure of the jet, what I'm quantity of the mist what I'm spraying per hour, or per you can say for particular time period. So these are actually new quantities. So then I can find out how much is it affecting, or is it affecting, or sometimes what I say is how much is this factor affecting. Means sometimes it is speed, feed, depth of cut. When I use this kind of things like pressure of MQL and the quantity of MQL, all this, then the effects of speed, feed, depth of cut on response will reduce, because these factors are coming in place. Right? So the 3 basic parameters for machining are speed, feed, and depth of cut. But it will be affecting somewhere on the response. Right? Only when these 3 are considered, they will be affecting. But when I consider again this 3 additional 2 or 3 factors, then the effect of this basic parameters on the response will reduce. But speed, feed, depth of cut, everyone knows that are the factors. Okay. So that is how things go on. So now for our example, it was like 2 to the power of 3. That is 2 level 3 factorial experiments. So I need to select 2 level 3 factorial experiment. That is full factorial. Next what I have to do? Next is I have to name the factors. What are the factors here? First one is number of persons. Second one is, you can write capacity of engine or CC of engine. Whichever, participants, please try to mention the names which you want to use it in your manuscripts or journals. So please try to see that, because this, as we know that these graphs are direct, you can import this graph directly, you can save this graph directly, and you can directly paste it in your papers. So please mention the right name of the factors, because this will be there in the graphs in the labeling section. For X and Y axis, it will be there. So we should be very careful when we are mentioning the names. Otherwise, what happens is once we go ahead, we can't come back. Again, we need to take a new design and then again give all these things. And at initial stage, it is fine. But when you have already given the responses, right, when the design is there and when you already given the responses, then again you have to do the complete process. So I say that firstly, you have to fix up what are the names, what you want to mention on the graphs. So CC of an engine, and last one was average speed. Hope everyone has done this. Yeah. So if everyone has done this, now first you have mentioned the factors. Now we have to mention the levels. So as I told you, 2 level. We are looking at only 2 level. So the number of persons for first one was 1, and the higher level was 2. For CC of engine, the first one was 100. The second one is 150. The average speed, the first one was 50, and then this is 70. Apart from this, if you want to mention the units, you can mention this was in cc, this is in kilometers per hour. Persons is just numerical, so I don't need to mention the units there. So dear participant, please enter this data, then we can go for the next thing. So design expert windows and full screen mode. Yeah.
Sir, one doubt, sir. If
Yeah,
at all we are not using any numeric values, only fact, suppose other than numeric values, if we are using, so how to define low and high in that case?
Yeah, usually then we have to do it categorical factors. You have to take it. These are numerical factors. Actually, if you see, I was expecting someone to point out this. Number of persons is not actually a numerical one, right? It's a categorical factor actually, right? 1 person or 2 person, right? So if I had taken instead of 100 cc and 150 cc, if would have mentioned like Pulsar and Splendor, then it is a categorical factor actually. Yeah, it is a categorical factor actually. So that thing also can be done. But what happens is then you have to go for blocking. You have to go for blocking for one category. If it's for 1 person or 1 category, you have to do one certain set of experiments, and for the other category, you have to do other set of experiments.
Other set of yes, yes.
Yeah, yeah. So categorical factors, that way we can look deal into, or we call it as blocking. So for block 1, the one category factor will be there. For block 2, another category factor will be there. Or else sometimes what happens is, I'll give you the one thing, that sometimes what happens is all the experiments, they are not possible to do it on one day.
Yes.
Yeah. So all the experiments we are not able to do it on one day. So what you have to do is you have to give one block where you'll be doing the set of experiments today, and you have to give block 2 where you'll be doing set of experiments tomorrow. So that way we can do it.
Thank
So
you.
if, yeah, welcome. So if this thing is done, I hope everyone has done this. I'll be going for the next step here. Yeah. So here they are asking for the response. What are you looking for? So I need to give the response. Yes, you can give with these are actually coded factors. R1 and A, B, C, all are actually coded factors. What you're doing is instead of coded, you are giving some actual factors. For us, it was mileage. Okay. What are the units here? Kilometers per liter. Okay. Kilometer, how many kilometers per liter I am getting? That should be my mileage. Okay, fine. So once you give this, again you can go for next. So now you'll be getting actually what you're looking for and how much percentage. This is actually all the part of software, so it will look into it. So don't worry much about this. Just see how the design power is. And finally, finish it. So once you finish it, actually when you give a coded factor, then this will be A, B, C, and the A, B, C, and so and so. It will be very difficult for us to conduct the experimentation or get the design. But when you give all the input data, right, the numericals and all these things, then it will be much easier for us to identify. Now, if you see two persons with 100 cc vehicle and 70 should be the average speed, kilometers per hour. So I can do the experimentation very easily. And now, usually when we see in all the journal papers, the run order will be in standard format. But if you see now on this, is the run order in the standard, is the design in the standard format? No, this is the standard. Standard format is 1 to, now order 8 expenses, so 1 to 8 it should be. This is the run order. So usually we have to do the experiments through the run order. As I told you, it is a huge importance because we need to avoid the noise and all those disturbances. So usually we need to conduct experiments in this run order. And most of the reviewers or let it be the panel, your guides and all, people will be asking you. The simplest first doubt what they'll be asking is, did you do experiments according to run order or standard order? So the thing is, for when you're mentioning it, you should mention it in standard order. And when you're doing it, it should be run order. So what do you think? The first problem when it comes is, if I close off this design export now, and again re-enter the data, the run order will change. It will not be constant. The run order will change. So that you should always keep in mind. Run order will change. So you can't say like, I can scan the system and directly I will put the response while doing experiments. No, what you have to do is, you write it down in a paper. All this design 2, 2, 1, 1, 1, 2, 2, 1, and this side is 100, 50, 150, 100. So these things have 70, 50, and all this. And keep it down with you on a piece of paper, and then go for experimentation. On the other side, on the right side, you just keep the note down the responses. Okay. And then you can close it down. You can close it down your design export, or you can save it. But basically, when you save also, this run order, again, when you open it, this run order will change. Okay. So this is one caution when we need to keep in mind. Then when you want to enter the data, you can just verify like this, and you can enter. And when you want to represent the data, just right click here, and you can go with like this. So now it is like a standard order. Standard order is basically which the coded factors I showed you yesterday in one tabular column, -1, -1, -1. First only it will be varying one factor, and then the others will be like this. So that will be there. So you can do this like, now it is the standard order, 150, 250, So it's just varying one factor here. Now what it's doing, it's varying this factor 1 to 150, 150, 50, 50. Right? So like this, it will go on changing. All right. So the most important factor is like, once you get this design, please note it down in your, this is a very small one, right? These are just consisting 8 runs. Sometimes we'll be doing full factorial like 80, 82, 84 experiments also, or 27 experiments also. Then there will be huge confusion. Now it is anyhow 8 experiments. So this is the next example will be of a 3 to the power of 3, 27 experiments. Then the entering the data is very difficult for us. Okay. So now this thing is done. I hope everyone has got this design. If you are not about it, please you can just respond in the chat box. Yeah. So if that is the case, let's share the screen. Coordinator, sir. PPT ఇక్కడ కనిపిస్తుంది full screen చేశాను. I can't find tab here. Need to screen as చేశాను because I need to shuffle both. ఇది అన్ని ఒకేసారి చేయలేము స్క్రీన్ లో ఉంటే ఇక్కడ ఉంటుంది కదా ఒకటి స్క్రీన్ ఇస్ దేర్ ఫైన్ బట్ ఇక్కడ పీపీటీ లేదు కదా ఓకే yeah so if everyone is done with this then let us go with our layout. Is this visible?
Yes sir.
Okay. So I have this thing now the mentioning recording the thing is very yes okay fine, thank you for this response. Now recording or mentioning the responses is very difficult task for us. Now let us see how we can mention. So if you see, this is the chart what I was asking you for preparing for yourself. Like keep it with a hard copy and on a paper or somewhere and go on writing the responses for various run orders. So I have done it, various run orders I have done it. Now I have to do what I have to do is I have to go on entering the data for one person 100 cc vehicle and 50 kilometers per hour. The mileage is 70. Vehicle 50 cc, it is 70. I need to mention 70 here. Next one is dear participants, are you doing this for one person 150? Don't say that sometimes the order will be different for you. This thing what is there, the order will be different sometimes. It will be 1 1 1 1 and then 2 2 2 2. So please just concentrate on the levels here in your design expert. Please concentrate on the levels. What happens is if I right click here and just change right like this, it will be 1 1 1 1 and 2 2 2 2. So please never concentrate on the levels here like this or the numbers or the run orders. What I'm saying is just concentrate on the levels for that particular run. The next one is 1 150 and 50. 1 150 150 and 50. It is 65. Okay. 65. Next one is 100. Sorry. 70. Yes. 170. It is 60 kilometers. per liter. So I'll be mentioning 60. Okay. Next one is 150, 70. 150, 70. 150, 70. It is 60 kilometers. 170. Sorry, 170. I have just mistyped it since 170 to 60. Okay. 150, 70 is 60. Okay. Next is 250. 250. Okay. So let me mention 60 here. Then it is 150 and 50. If possible, you can do the split screen thing also. But let us see 150 and 50. So where we can have 150 and 50, it is 55. Then you have 270. 270, it is 50. Last one is 150 and 70. 150 and 70. So this is also 50. So please, yeah. So yes, if you have not entered the data, please from this screen you can just please enter the data. If everyone participants have entered the responses, then we can go ahead. Or please verify also the data. Yes, please, if all the participants have entered it, please cross verify the mileage issue. Because sometimes if you have entered the wrong data in one of the columns, the output will be different for us. Okay, can we go ahead? If anyone is, everyone is done with this. Dear participants, can we move ahead? Five minutes. Okay. Yeah, sure, Sandeep. We can wait. And other participants, in the meanwhile, please don't feel offensive because doing this thing takes some of our getting used to it will take some of the time. In the meanwhile, if you want to discuss some of the doubts, we can go through it also, like the area of work, what you are doing, and if you are willing to use DOE, is it feasible or using DOE, and these things we can look into. So please feel free for communicating. Yes, you can communicate in any language. It's not only about English. Right? It may be Hindi or Telugu or Kannada or Tamil somewhere. I can't understand much of it. So Mr. completed, but order was not the same according to. Yes, that is what I was saying. The order will not be same, Sandeep. So actually, what happens is this will be shuffling each and every time. That is what I was saying. Just go with the data which is available, like or the levels. This is the run order, right? Let us take run order one. I'll just rearrange it according to run order. Okay, rearranging it. So what happens is this thing will be common, 270, right? Two persons with 100cc vehicle and 70 average speed. For that, I need to write out 50. So that is how I need to go on finding the thing, and then I need to enter it. There are some tricks actually which we can do it, like arranging this ascending, and then again this as ascending, and or this as ascending, sort by ascending. Then finally I'll do for this. Yeah. Yeah. So this way, okay, or you can go with reverse way. From here I'll start, then ascending, and finally now if I go for this, yeah. So now I got it right. So this is how you got the standard order. So this is how we can get this. So yes, sometimes you have to do some manipulations, which right, it will be coming from experiences only. So 1 1 1 1 was the 2 2 2 was the year 100 then 150 150 100 150. So here it will be varying. So this is how your this design with coded factors is actually mentioned. So hope everyone has done with this. So you can go with column information. What are the columns? I mentioned rightly or something like number of persons were low is high is 2, capacity of engine units for cc. This is a factor actually, and then low level was 100, high level was 150. By chance you have done some misinterpretation or by entering, so you can just clarify that. So the average speed is this. So the mileage. What I don't know why he has given the mileage 50 and 70. He has to mention it, right? So once this thing is done, the information, this part, if you see on the left side, if you see this tree, this is the will be available here. This is not summary. You can go summary. You can know about how things are going off. So if you look at it, you have some built information. How it is built, how many factors were considered, 2 level factors were considered with 3 factorial experiments, 2 level, 3 factorial experiments are there. This is like information regarding the software, right? So like a 12 version, and runs, how many runs you are doing, 8 runs you are doing. Blocking, I have not done any blocking here. Center points are not there. Then you have this factors, regarding the factors, the information is here. Minimum and maximum levels are here. Coded level is -1 1, -1 100, and -1. So for -1 is 1. For year for cc of engine it is 100, and for average speed it is 50. So lower end it is 150. For higher end it is 2 150 and 70. So here also you have not done any mistakes. So this thing is fine. Mean and standard deviation, you will be knowing it. So these are some of the informations and responses like you are looking for. The mileage with 8 observations means 8 runs. You are going for factorial experiments. Minimum is 50, maximum is 70. That is what he has taken as default, but that is my standard deviation ratios. So these are some basic information which you will get from this. And then what you have mentioned, how did you mention like the values, what you have entered. For one person, what would be the mileage? And if I change year, number of persons is there. This x-axis is number of persons. Just if I change this number of persons to cc of engine, then how many points I've entered, will I have entered correctly? So for this thing, for 150, I have 4 readings, 1, 2, 3, 4. For 100cc, I have 4 readings, but you see 1, 2, 3, and then this here it is 4. So 4 readings I have entered here. Then let me go for average speed. Yeah. So average speed, what for average speed when it considered with mileage, we have mentioned 4 here, 1, 2, 3, 4, and at the same time here at this point we have 2 values, and at this point we have 2 values. It's just you need to just know like the data what you have entered is right or not, so you can just clarify with this kind of things. So Ram, this also you can look at it. How is it? But not, we don't require this. We don't represent these things in the thing. Yes, this is one, but I don't need this. But still, you can find out, because without analyzing, I can't do all these things. So this is just for your thing. We have some interactions also: AB, AC, BC, and ABC. All interaction things. So when we consider this, results and graphs are not required here, but still. This all we don't use for representation, so you don't need to worry about these things. Go for direct analysis now. Once you go for analysis, let us see. On the mileage, means this is the response what I mentioned. So now, when you enter, when you click on the mileage, I'll just make this, bring this down. So when you click on the mileage, one screen of this kind will be visible for us. So usually what we do is, initially we keep it none. We don't need any transformation things. I'll keep it on none. If it is there, then box the graph will tell me actually if I need any transformations. Now you have to go sequence-wise steps, like we do in answers and all that. We need to go sequences. After looking at transformation, I need to go for effects. Then in the effects, I need to select the effects what I'm looking at. Then I need to go ANOVA. Otherwise, if you go directly ANOVA, model not analyzed. So once the model is not analyzed, you don't get any ANOVA there. Right? So it is redirecting you to effects. So first one was transformation. So once I have done transformation, I will go for effects. So what are the effects now that I am looking for? Go for numeric area. So initially no effect is selected. So this chart is there, right? This chart is not readable here, but I'll go if you want a summary and evaluation. So not here. Okay, so okay, anyhow, let us go back to mileage itself, and here we can see. So usually you have to double click on the effects. Like, let me click on number of persons, then CC of engine, then average speed. I have taken 3 effects, and I am seeing the normal plot. Usually this normal plot should be straight enough, so that you know that there isn't any effects. If I do something else, it will not be, it will change its shape, or sometimes the ANOVA will not be visible. So this part is actually from the ANOVA part. So depending on if I can select all the things, but sometimes the ANOVA will not be reproduced. I don't have any F value and I don't have any P value. So I have to go back here and unselect these things because they will not have any interactions. So at present, what I'm doing is I am taking only 3 main factors. That is number of persons, CC of engine, and average speed. These 3 only I want to know, because this is my basic study, and I want to only know the factors, effect of the factors. I don't want their interactions effects on the response. So if I go back now to the ANOVA, yeah. So once I click on the ANOVA, then ANOVA table is now visible. So actually, if you see in ANOVA table itself, the complete information is already mentioned. So you'll be knowing how the ANOVA table is there, and the reading the ANOVA table also. But let me give you one glance. If you see here, number of persons, F value. Actually, if you see the value of F will give you the significance actually, or you can not significance, or you can select the contribution caution. Like it shows around 64%. It contributes on 64% equally. We have some other things that I'll be telling you later, but this is the highest. That shows 64. F value is 64. So this is the number of persons is contributing more towards the response. Then CC of engine is just 4. F value is 4, and average speed is 36. Sorry, so it's contributing 36 somewhere. You can't say contribution, but this 36 value. So if you see the p-value, the model directly it sees here, like p-value less than 0.05 indicates model term are significant. So in this case, A, C are significant model terms. A and C means number of persons and average speed. Both are significant factors. Means they have some notable effect on the response. But CC of an engine is like, see, what is it? 0.1161, right? So this actually is more than 0.05. So this is not significant. That is the term what we'll be getting into. Yes. Apart from this, the most important thing is R predicted R square and adjacent R square. Right? R square value, or you can say adjacent R square value. This both values which are there should be more than 0.9. So usually we do some set of experiments. We think that the data is okay, and we keep it in the design. And finally, when we come to ANOVA and when we see R square and adjusted R square will be 0.8, adjusted R square will be 0.6. Then your paper will not be accepted. What they'll be looking up at is the experimentation what you've done is wrong. That is what they'll be giving a statement. Why you may be saying, no, sir, I have done all the experimentations perfectly. I have taken all the readings perfectly, all this. The problem is not, sometimes it may lie in the experimentation, that is fine. But sometimes what happens is the levels and factors what you have selected itself is not appropriate. Then if that is not appropriate, the values what we'll get will also be not appropriate. So everything is interrelated, like the Six Sigma, right? When we consider Six Sigma quality checks, from the raw till the final product, everything at every step it has to perform to 100%, right? So this is the issue with this. So most of the experimentations when we do, we'll be getting the data. We have done experimentation with the design, everything, but when you come to the ANOVA and your R square and adjacent R square, apart from this, they will not above 0.9. It should be usually, if you have done it very good with caution, then it should be above 0.9, and this should be also above 0.9. Yes, sometimes with Taguchi or some methods where we have very less number of runs, this can be above 0.9 and this can be about 0.8, 0.85. But the difference shouldn't be more than, it should be, the difference between these both should be less than 0.1. Then only your data is good agreement, and the regression equation what we get from this kind of data will be reliable. Otherwise, your regression equation what you get is not reliable. So that is what he is saying. The predicted R square value is 0.8519 is in reasonable agreement with the adjacent R square. That is, the difference is less than 0.2. That is their case. Your model is significant. Then adjacent R square measures the signal to noise ratio. So this is what you know already. Ratio greater than 4 is always desirable. So your ratio is 16, indicates an adequate signal. This model can be used to navigate the design space. So he mentions this clearly. So this data, it is mentioning clearly everything. So DOE with DOE, this is the advantage.
Hello, sir.
Sir?
Sir, sorry for interruption, sir. Sir, last 3 minutes my power cut, sir. Can you resume this from FX, please, if you don't mind?
Yeah, sure. Yeah, I'll do it. Effects, right? Okay. Yeah, let us go with effects. Usually, now it's visible, right? Screen is visible. You are okay?
Yes, sir.
Yeah, okay. So this is the screen, right? Usually effects, when it comes to effects, you need to select the effects for which you are looking for the ANOVA and the complete analyzing part. So you need to know, for my preliminary study, what I'm doing is, I don't want to know what are the these factors are affecting the response. That is what I'm looking into. So I'll be selecting only the main effects. Like if I double click on these things, it will be representing M. All right. So these three are the main effects for me for the study. Okay. So once you've done this, you go to ANOVA. Then the ANOVA table is already being displayed here. So if you go to the ANOVA table, now let us see. F value here tells us actually which factor is affecting more. Here, number of persons, that factor A, that it is 64. What does that mean is, this is the factor which is affecting more on the response. The second factor, if you see, it is 4. So it's almost minimal. The third factor, if you see, it is 36. So this is also the factor. So the first factor which is affecting the most is number of persons. The second factor is average speed. Then you have p-values. So what is saying is, if the p-value is less than 0.05, indicates the model terms are significant. If you see, now p-values for number of persons is 0.001. If you see capacity of engine, it is 0.1. It is more than 0.05, right? So this is insignificant term. Then average speed, if you see, 0.0039. So this is also a significant term. So what is saying is, indicates are significant. In this case, A and C are significant model terms. The values greater than 0.1 indicates the model terms are not significant. That is, engine capacity or capacity of engine is not significant for this. So this is what we were talking in the yesterday's session, right? We were thinking that capacity of an engine will affect the mileage more. But finally, when we studied, capacity of engine is not affecting, but other conditions which are there. If I'm riding with a rider and a pillion, or I'm just cruising at an average speed, less average speed of 50, and all these things are much affecting factors. Okay, so this is one part of looking into ANOVA. Apart from that, R square, predicted R square and adjacent R square should be in a considerable range. Otherwise, what they say is, you have not done experimentation correctly. If you have not done experiment, then you'll be asking, sir, no, I have done the experimentation, I have done the DOE with very caution. I have taken the readings, maybe the wear rate and all these things. I've done it very cautionly, but still my predicted R square and adjacent R square are not in good agreements. And they are not at a higher end. Here it is actually predicted R square is 0.85 and adjacent R square is 0.9 and R square value is 0.96. Usually what is expected is R square and adjusted R square should be above 0.9. Then only you have done experimentation correctly. Most probably sometimes what happens is, it may be due to, yes, everything what we have considered and then we are doing is maybe right. But sometimes the factors and the levels what you have selected may not be right. So at each and every stage, we have to see that we are doing the right things. So from selecting the levels, from factors, and doing the experimentation, taking the measurements, and noting down in the design also is an important factor. Right. Apart from that, what you have to look into is the predicted R square of 0.8519 is in reasonable agreement with adjacent R square, that is adjusted R square, that is 0.93. I told it is differentially 0.1, but if you do it difference, if it is below 0.1, it is very good. But at the max, the difference should be 0.2, where it is unavoidable reasons, unavoidable conditions are there where I can't do it. So that should be there. Apart from that, adjusted R square measures the signal to noise ratio. So adjusted R square measures the signal to noise ratio. So a ratio greater than 4 is desirable. So our ratio is around 16, indicates an adequate signal. So most probably it is this design expert is asking the question, at the same time is giving the answer. It is not stressing us. Okay. We can rate it as a very good software. Okay. If you go with the older versions, everything will be in a one sequential manner, but this is an higher version, so all in different tabs it has given up, different windows it has given up here. Then once you get all this, then you go for coded equation. If you go for coded, you want to mention a coded equation in your papers, then you can mention this like 58.59 minus 5 into factor A minus 1.5 into factor B minus 3.5. Or if you want to get the actual equation is like this: 102.5 minus of 10 into number of responses minus of 0.05 into cc of engine minus of 0.35 into average speed. So this is the regression equation. Yes, if you go for RSM, it will be much complicated regression equation. And if you consider some interactions also, again, that things will be mentioned in the equation. But it depends on now how good a regression equation you want. And the better one is in RSM. So RSM will be having a complete day on Friday. So that day you'll be getting a complete idea of the regression equation. And from there you can go for optimization and all that things in RSM. Okay. So once this thing is done, we go to diagnostics.
One doubt, sir. One
please.
question, sir. At the regression equation, the coefficients, whether they are the Pearson coefficients, sir.
Sorry?
We have this
I'm not able to understand.
Coded equation, actual equation, and the coefficients here. Beta something here, it's showing there. Are those correlation coefficients?
Beta, I can't find. I am not finding it here. It's visible, if you can see.
Before coded equation. Yes.
Coefficient, okay. Yes, in this?
No, I don't think so. They are correlation coefficients. Okay, these are only the coefficients of the equation.
Yeah, for the equations only.
Okay. No. Then
as we are not given, we are not given any interactions at present.
Okay. No,
okay.
Actually,
so that is why
I am working in Minitab, so there we can directly get the correlation coefficient. We are getting the correlation coefficients here.
Okay.
So I interrupted.
No, what I thought was you would have you would have considered interactions. It seems. So.
Then where to get the correlation coefficients, sir, in this?
If you have considered interactions, it may come up.
Okay.
You need to consider interactions. I have not considered the interactions here.
Okay, sir.
Okay. Now we need to go to diagnostics. If you see the diagnostics, as I told you, Bob-Cox plot, if you see, in this one, recommendation will be there, recommended transformation. It is recommending none. As I told you in the starting transformation, recommendation is none. Initially, I will do it with none. But finally, when I see and in the diagnostics, if it is recommending, lambda should be equal to 1. But if it is recommending something else, like lambda to the base 10 log or natural log or square root or some transformation, if it is required, the software itself will tell then this transformation is required. Then the procedure what we have gone through should be again repeated, and then you have to go for the effects, then the ANOVA, and then come back to diagnostics. So this is regarding some the normal plot which is there. We have predicted versus actual plots regarding the regression equations. Then residual versus prediction, residual versus run in any of the papers. So this is just for our understanding. Then the major part what we'll be looking up is this beautiful graphs which I showed you yesterday, isn't it? So what does it look as? Y-axis is mileage, that is the response, and this is the factor. So number of persons, how it is affecting the mileage. So this is the range actually, that is what it is giving up. I'll tell you the beauty of thing here. If I want to know the value here, just put the cursor here. It will give you the value, that is 65.48 on the bottom left corner. If you can see, you'll get that value 65.48 and if you go below, it is 62.01, and its average is 63.75. So this value you can get it. If you are not satisfied with this graph and you want to represent it very beautifully using some graphical softwares like Origin and all these things, then you can do this. In Origin also you can have this marks, this range of it, range, right? So plus or minus, so these values you can get it. At the same time, if you go 53.75, here it is 55.48, here it is 52.01. So this is how you can extract the data. Apart from this, if I want the same thing to be representable, if you see this XY, the labeling on the Y axis and the X axis are something much smaller when compared to. So if you're satisfied with this, and if you're using this size of image in your paper and do it in Origin, that is also fine. You can represent that also. So usually when you're comparing 2 or 3, as in the earlier discussion also, as I told you, right, one design was separate, other design was separate. So how should I combine that? Then this is the way how you can extract the data for plotting the graphs. So then I will change the condition and go for B, CC of engine. So this is the graph for CC of engine. Then I'll change the term here again. That is average speed. If I want to individually download this, just right click on the graph, and we should add export here. We have this export. Just export to a file. You can export to a Word, you can export to a PowerPoint, or you can export to any file. It can be a PNG file, it may be. So you can export to that, and you can just directly save it. And this is just one factor. If I want all factors. So if I want all factors, so this is how you can get it up. So all the 3 are here. Okay. So this also you can just right click. You can copy or you can export. Just export it. That would give you a good high quality image. Okay. So interactions we have not considered, but still, if you want to represent it, there isn't any interaction here between A and B. There is number of person and CC of engine. If I want to change the thing, I can change terms. I can change this here. B. Okay, this is individually, but still I'll go for interactions here. Okay. And average, this is kept at low. I can just change it. You can also find with the change in average or average speed, is there any interaction? No, we can't find any interaction. So that is fine. If you want to plot some contour graphs also, with this you can plot it. Okay. So what I would recommend is, this is the ultimate thing. ANOVA table is the one which first thing is the design. What in papers, if you are representing, the design is the major part. It should be mentioned in the paper. After that, ANOVA results should be mentioned in the paper with R square, predicted R square, and adjusted R square should be mentioned in the paper. And after that, these are the model graphs which you should mention in the paper. Okay, so this is one thing. Apart from this, you can go for optimization. Numerical, you can say what are you optimizing is the mileage. I want optimizing the mileage here, and I am going for some solutions if possible. So you have to give the criteria also. I have given mileage, but goal, what I am looking for, lower the better or higher the better. You should just target that. Usually if you go for this, we go for only my response. So higher the better is what I'm looking, that is maximum. Okay, so once that thing is done, let me go for the solutions. So what it is saying is, with one person, 100 cc vehicle and 50 will give me the highest mileage. That is what it is saying, but the graphs are saying something else. But that 150 cc also is okay, desirable, a desirable thing. So these are all the desirability criteria it will be mentioning. So there are n number of desirability criteria, so around 68 solutions it has given you. It can be done, but sometimes this thing is like 100 point this and it will give in the range of the levels what we have mentioned. So 104, 106, this we can't change, but you can do this, but it's not required. From the paper point of view, this is not required. The reserved solution is not required here. So this is a whole thing that we can do with design expert. And before going to all these things, I want to end this thing at present, and I want to start with general factorial one, because already we have only half an hour remaining. We are running out of time, and we have consumed most of the time with the simplest example. Let me take a new design, and I don't want to save this. So I came to a new design. Now, let us go to the PPT and let us find out actually which problem we are taking. Okay. Yeah. Yeah. A most common example where cutting speed, feed, and depth of cut are there. 3 factors and 3 levels. Okay. So as I told you, 2-level factorial experiments are the most basic type of experiments, but 2 levels will never give me any good result because if I take 2 levels, it is just a 2 points where just it will be joined by a straight line. I need the third point, because I don't this is when you want to join two points, it is just a straight line, but in between how it is varying, I don't know. So what I have to do is I need to consider a point which is in between. Okay, then only I will know the trend. Sometimes, yes, it may go up and come down, or somewhere it may go down or go up. I don't know actually, depending on the response what I'm looking up into. So when you are doing a work for a paper, don't consider 2 levels. It is always recommendable to go for 3 levels, at least of 3 levels. Okay, so that is why this is most important example for us. Where we are going for a 3-level factorial, 3 factors full factorial experiments. Okay, so before entering the data, let us go here. Where can we find it? Go to optimal or custom design here. Somewhere, if it is an older version of DOE, it will be just general factorial. Otherwise, you can have here optimal or custom design. In optimal or custom design, I'm going for 3 factors. So I've kept 3 factors here. Okay. Now let me mention the factors: cutting speed, CC of engine, and average speed. So we have here units. This, I think it is in RPM. This is in CC. Sorry. So still I'm in that problem itself. So millimeter per revolution, and this is depth of cut in millimeters. Okay. Now, as I told you, it is 3 levels. So I need to mention 3 levels here and enter. So here also 3 and enter. Here also you should mention 3 and enter. So once this thing is done, you have given all the basic things. Did we give all the basic things? Not yet. We need to mention the levels also. For cutting speed, it is 420, 600, and 850. So here it is 420, 600, and 850. For feed, it is 0.1, 0.18, 0.33, 0.18, and sorry, 0.18 and 0.33. The depth of cut is 0.5, 1 and 1.5. And 1.5. So once I have mentioned all the levels and the factors, let us go for next. Then here, I am considering 3 factors, right? Initially, it is taking us 2 factors. I have to edit the model and I have to go for 3 factors. Okay. Once this thing is done, usually 3 to the power of 3 is 27. Required model points are 27. But the software itself, it's having some lack of points and it is giving up extra additional 5 points. That is making the total runs into 32. We don't require this initially. So what I'm doing is I'm a lack of fit points. I'm keeping it to 0. I'm restricting it to 0. Now, next, I'm giving the response. Responses are A, surface roughness. Here, it can be in it can be micrometer, okay, and then I will just I couldn't insert the symbol. That should be okay. So micrometers, you can just copy and paste also from somewhere the symbol micrometers. Then next, then I finish it off. So once this thing is done, you will be getting a particular run order. Okay, so once you get this run order, you can look into it. The same way you can do it as we did it, sort by ascending order from the last factor, so that entering the data will be easy. Okay, so for 420, 420, 600, 600, 850, so like this we'll be having around 27. Okay. So now I'll be going through the PPT and I'll be looking into like please you can just copy it the data directly and you can paste it up if your design is in this order. All the data level. Dear participants, I know that you don't have the data to copy and paste it up, but yes, we'll be sharing the PPT also, as already we have only around 15 minutes remaining. Or open the old saved one.
Excuse me, sir.
Yes, sure.
Sir, no problem about time, sir. You can take your own time. You are teaching very nicely. Go ahead, sir.
Thank you, but I have my own restrictions in the department.
Okay.
Yeah, so yeah, we can do it if you are. I'll ask the coordinator to share these points. Otherwise, you can't do this complete. If it's possible.
Okay.
In the PPT, we'll be sharing you. If possible, try to copy the things.
Okay, sir.
Yeah. So till here, I think all the participants are okay entering the data and getting the design. Now, after this, the procedure is same. I'm just waiting for coordinators to share the PPT. Yes, participants, the PPT is shared in your group. Just browse through the PPT and yeah. So from the PPT, go to it's slide number 39. Directly go to slide number 39, and from there, as I gave you the order, so you have to paste it in the same order. Please don't change the order, otherwise the values will be completely different and we don't get anything to look up. So as I told you here, first from the last factor, go on arranging in ascending order. Right click here, as already I mentioned, so no problem here. Ascending, and ascending. Then you will be getting the same value which we have on the PPTs. So then you can directly copy paste these values in the design. In the meanwhile, dear participants, I am fortunate enough to have this session, that is a hands-on session where we can do most of the discussion part. So actually, when we were planning this STTP, the most in the physical mode, the intention was asking the participants to do some initial small experiments like mixing the sugar in water with the RPM and the size of the spoon, or how many revolutions per minute you are rotating the stirrer, and all these things, like small experiments we were planning of, so that each and every participant will have their own data. With that own data, they could analyze the things. So that was the whole idea. But unfortunately, everyone has to stick onto the monitors, and we have to do it virtually now. For practice purpose, I will recommend for participants to select any of the journals from the website which are suitable for that particular designs. And you can. This is actually from a paper, journal paper. This data is from a journal paper, so you can just use this data, and you can practice this anytime in your free time. So. If you want to know how it is behaving, or if the paper have those who are mentioned, they have done it rightly or they have not done it rightly. Sometimes what happens is they'll be mentioning it R square will be something 90, but initially when we do it, it may be some manipulation. So these things also maybe actually you can say that this thing also can be identified, because sometimes you take that when you're doing some research. Actually, I'm getting some disturbance from one of the participants. Yeah. So what happens is, initially what happens is we will be taking some journal paper as our reference, and we will be relying on that journal paper to support our results. But we have to also see that as an you can call it as a genuine researcher or some way. So we should also check that by keeping the data and analyzing the data by yourself, and seeing that actually yes, what the other persons have reported is the facts. Okay, so that is what we should take responsibility, being in a research community. Okay, so try to see that you do the experimentations very in a very good manner with all the cautions. Yes, if this is done, we can go ahead. If anyone requires time for doing this, entering the responses, you can please mention the chat box, or you can tell us how much time do you require for that by unmuting your mics. So I hope everyone has done this. Let us see one by one. Some column information is there. That is okay. Then we have summary. For build information, we have some summary here. For factors, we have some summary. And responses also we have it. Some column graphs are there. How you enter the value, you can know actually how you enter the value. So you can just change it. This is for depth of cut. You can go it for feed, and get this data. So this is okay, but this is just for the information of the design what you have done. But these things we don't report in the paper. What we have to do is we need to do analyzing. First thing is default it is taking inverse square root. Let it be for timing. Let it be for timing. Then what I do is defaultly it is taking A, B, C, and this all things. Let us say if ANOVA part is there. ANOVA it is not. P value is greater than 0.001 and it is significant. It is showing that. So this should be okay. Or else I'll try to reduce the effects. At present, I will be just taking the main effects for making the things easier for us. I'll be taking the main effects just, and then I'll go for ANOVA. Yeah. So now it is as we expected. Right? The model value of 0.2 implies the model is. First, you have to see that the model what you get is significant. Then what you're saying is the p value is less than 0.05. Then it is not okay. So if you see the major affecting, as I told you, it is surface roughness. So generally, if you see all the studies, we know that feed is the major factor because feed leaves the feed marks on the workpiece, and we measure across this feed marks. We measure the surface roughness across this feed marks. The more the feed, the more the surface roughness will be. The less the feed, the less the surface roughness will be. So that is the ground rule. So we know that factor F is feed is affecting the most when it comes to surface roughness, and depth of cut is not a significant term here because it is having p value more than 0.05. The depth of cut is not a significant term, but yes, speed and feed are the two significant terms which is affecting surface roughness. So most of the study, if you see blindly also, if you go when it comes to surface roughness as an output or response, feed and speed. So speed and feed will be the two affecting factors. Then you can go for fit statistics, model status comparison, or like coded if you want the equations. It's like coded or actual. No available because the model contains more than 12 categorical equations. The limit can be increased in the preferences. Yeah. But if you see this, what is happening here? Or let us see this transformation diagnostics. Let me see if any transformation is asking. No recommendation. Lambda should be 0. Is the lambda at 0? You have to check it up here. If the lambda is 0, yes, it is showing the lambda is 0 anyhow here. This is why lambda is 1 here. As lambda is 1 power. We don't need power. Natural log. We have to take natural log basically. So there the lambda value is 0. Now again you have to go back here. Okay, then I'll consider this. I know I will not consider this. Then I'll go for ANOVA. But still, if you see, I have taken the recommendations already from the lambda. So lambda should be 0. So that transformation already I have done it. Natural log lambda it is showing 0. This transformation already I have done. Okay, I have selected the effects also. Now if I go for ANOVA, then see R square value and adjusted R square value and predicted R square value. What I'm saying is predicted R square value is 0.4675 is reasonable agreement with adjacent R square. Yes, because it is difference is less than 0.2. But as I told you, that should be around 0.9. R square value should be around 0.9. If it is not around 0.9, that means you have not done the experimentations correctly. So should I rely on this kind of data? This is one of the data from one of the journal. This is the data from one of the journal paper, isn't it? So if I look into this, the equation what I get, okay, now equation is not possible here. You just only get the coded equation here, okay. The equation in terms of coded factors can be used to make some prediction, that's it. But will I rely on this data is the major question. So that is why what happens is, so when you mention in this paper, ANOVA table is actually required. So for all the journal papers, ANOVA table should be mentioned. Where or ANOVA table, what does it do is, at least it will give you an thing, or you can say the confidence level that your regression equation what you have considered is valid. Otherwise, simply it is just an regression equation for fitting up this data, but it is not significant. The p-values what you get, okay, should be there. And apart from that, the R square values should be 0.9 and above. Adjacent R square also 0.9 and above. Predicted can be less. But this is the standard procedure that that we follow. Then diagnostics, anyhow, as I told you, we can do this diagnostics, but we don't use this. But use this Bob-Cox plot for seeing the recommendations. It will directly recommend you which kind of transformation is required. And the most important thing what is required is R plots, model plots. This is the most important thing for us. So I'll just okay. So I can just record it, or as I told you in the for the last example, if I am not satisfied with the things here with the labeling of x and y axis, I can just get the points from here. Just keep your cursor on that point for which you want to note. On the left bottom corner, you'll get the value. For it is like 2.9. Here it is 4.82, and here it is 2.28. And if I want to know the margins also higher and higher lower value, just keep it cursor on that so you can know 1.8 it is here. Here it is 2.8, 2.89 somewhere, right? And for the other factors, just I have to change the terms. See what is happening. Initially, it is surface roughness is reducing, and then it is shooting up. So what I can say, if I want to analyze, so let us analyze one graph. Let us take one graph. So what it is saying, initially, when we increase the speed from 420 to 600, the surface roughness is increasing. That means maybe the other factors are influencing here. And after that, surface roughness is reducing. Actually, when the speed increases, surface roughness should reduce. But due to lack of some experimentation or some problem in the data, they're getting these terms. So here, that is why, as I told you, right, the R square value, what you're getting is not according to the desirability, 0.9, right? This is the problem. Usually when you see, in general terms also, when the speed increases, the surface roughness value should come down. But with this, it is not coming down. Initially it is increasing, then it is coming down. What does that mean is, the data or the experimentation, there is some problem. Okay, then let us go for B. Here also, what is it happening? As the feed increases, blindly you can say that the surface roughness should increase. But what is happening here? Initially it is high. When it is increasing, feed is increasing, it is becoming low, and then it is directly shooting up. Yes, this can be explained, but how will you explain this part? I am more worried about this part which is there, this graph which is there, this reducing in the surface roughness. This is the major part for me. How will I define this? Yes, I can say some other factors like depth of patterns or speed are influencing, but how much will it influence? Will it go with the negative value? No, I can't say that. Yes, I can define this slope because this very steep. But how will I say this one? This is the biggest problem. That is why I was saying, that is why we didn't get R square value and predicted R square value good. The depth of cut, what is saying is negligent. Yes, this graph is okay, fine for us as the depth of cut is increasing. A bit increase in surface roughness can be found. Yes, this can be somewhere reasonable graph. But how about the other two? That is why that R square value, predicted R square value, adjusted R square value says that how good you have conducted the experiment. That is the biggest thing for us. And then coming to all factors, so this also you can just right click and then you can just save it off. And the other things are as usual, contour plots if you want, or predicted residuals and all this. But the main thing what today's concentration is this thing. So with this, I would like to end this session. I hope I was a bit faster for the second one. So if we have any doubts pertaining to these things, we can please go ahead and have some discussions. Because what I mean is like discussion is the major part of anything. If you want to learn or if you get some confirmation, discussion is the ultimate part. So far, if you is there anything that we can discuss, then please go ahead. Dear participants, anyhow, we have given this graphs and all this in the PPT part. Yes, you can go through it. Apart from that, selfly also, because the things what were considered were different for this. We have not taken any transformations and all that. The results will be somewhere different for us. Yes, if you do like this, it is like there is a huge difference in adjusting predicted R square here. If we go in this way also, there is a huge difference. It is more than 0.2. So it is not recommendable also. So if you just change it, yes, somehow you get by changing the effects and all this, it is like you can take 0.9 R square you can achieve with the same data. But how will you reduce the effects between both these two? So somewhere or else the experimentation what the paper has reported is not right. So apart from that, if I can help you in any way, please feel free to express yourselves.
Hello, sir.
Hello.
Sir, can you explain about this predicted and actual graph, sir, please?
Predicted and actual graphs is from the data itself usually. The regression equation what you get, the same values you keep it in the regression equation, and the values what you get as a response from the regression equation, you will plot it against the ones what you have done experimentally. So that is what I was not concentrating much on this, because this is just a normal thing. So and that graphs you don't report even in any of the journals. So.
Okay, sir.
Actually, sir, it is like suppose if you are trying to use the regression equation and then trying to use it for prediction, then if they are substituted for the same values, how are they behaving? Like if you take the normal plot and then see this is the actual value, and using the regression equation, if you are substituting the same value, this is the predicted value. So the deviation. So that what is the indication?
Okay, sir.
And dear participants, one more thing I want you to keep in mind is this regression equation what you get is limited for R levels only, for R conditions. So in between that, if you want to do that points, you want to go beyond the levels, then regression equation, you have to take it for optimization and all this. And after that optimization, if you get some equation there, then again you need to do some experimentation for the points what you got. You can validate the things. So that is again a huge task. So usually people stop with the regression equations, mentioning the regression equations.
Okay, sir. Thank you, sir.
So it all depends
Welcome.
on what you want to do, sir. Suppose if you want to only understand the main effects and interactions, I think whatever sir has mentioned up to this, it is sufficient. But if at all you want to go further step ahead and then try to see or make use of the regression equation that which is proposing, and then use it for optimization, or make this equation as objective function for optimization and other things, then I think this with the predicted R square and the adjacent R square, it is not suitable. So maybe you need to use something else like RSM, where the model is used basically for predictions and all.
Yes, sir. Yes, sir.
Yes. So it's still open for discussion. It's still, we have some more time left. So if at all you have anything to ask, please let us know. And I'll be sharing since the system has been changed because of the difficulty in laptop. So I'll be sharing the feedback link just after this session. 5 minutes. I'll just take 5 minutes to share the feedback just after ending the session. I'll share the same in the WhatsApp group directly. So from there you can give the feedback.
And participants, please, it's one more thing that if you come up with any such kind of difficulties during your work, feel free to contact the coordinator. We'll address your things. So it is like building up a scientific community and building up some community and having some communications between us to have this relation or maintain this relation. So at any time of the day, like you can call us or you can contact us and just post us what is your problem. We will be it will be like, for us, it will be like a privilege for us to expand our knowledge and then give you a solution. So we are there for at any time for you. So.
True. So it will be good if we can be of some help using this HTTP as a one platform. And we are also looking forward to introduce the videos in another platform, so that in the forum form, so that we can have this discussion continued even after this HTTP program, and that may invite even others. So I'm having a couple of such platforms already in mind, like course networking is there, one CN. I don't know. I hope some of you might be using it. I think we can use some of such platforms where we can post the same videos and also have the discussion continued. So even I can ask or request our resource persons to be also the members of these forum, where we can discuss directly, like whether this is the selection what I have done and is it suitable for my type of problem statement or for these objectives, like others, those who have interacted today. So this is what is generally is a problem, where most of them don't sure about their design, and they'll come to know only when the reviewers comment. So by that time it is too late, and only thing that we can do is do the justification of whatever we have. So before even continuing the experimentation, we can have clearance from the expert saying that yes, your design will be suitable for your problem statement, and then you can go ahead. So that's what we can do. Yes, we'll try, sir. Could you please share any contact number? Yeah, it's there in the brochure, ma'am. So it's already available. If I can also
One more thing, I wanted to add up, if you want my number, or it's like the coordinator number, so it depends now again. So if that is the case,
I think in the last slide it is there. Okay, it's not there. Okay, fine. Never mind. I'll share those. I think he's also part in our group, WhatsApp group. So you can get that. Okay, sure.
Hello, sir.
Directly.
Hello, sir.
Yes, sir.
Sir, can you give 1 minute to express my thoughts about this FTTP?
Sure, sir. But I want you to hold your thoughts even for the validity. Of course, I am not stopping you now because it's recorded. Yes, please.
Sir, actually, I need to tell one thing about the communication. You are sending message at very fast. I am sleeping in the what very very easily I can communicate with the you people, sir. You are organizing such a wonderful way, and communication is very very fast. And so as of now, I am feeling so good about this workshop. I am learning something about this device.
Thank you,
Uh,
sir.
and especially Varun sir, you are doing fantastic job, and you are organizing all those things, and you are giving instruction. Try to join at sharp. These are the things are motivating the people to join the session at as early as possible. And you told us, sir, that one platform you are going to make, that will be useful, sir. Being an expert in that panel, then before going into experimentation, we need to thoroughly check the model whether it is valid or not. That will be better, sir, if you making that platform. That will be very very beneficial for scientific community, not only for the research scholar. That everyone will get beneficial to share their ideas about the model and design. Thank you, sir. Thank you very much for giving this opportunity.
Thank you, sir. Thank you very much.
Yeah, thank you. Actually, I wanted to mention coordinator said this. I just wanted to just interrupt you. Yeah, I know it is actually difficult to cope up with the resource person here and do it parallelly and understanding it. Yes, like a kid, we can just copy paste and do it. What are the procedure steps, and we have done it. But practically, when we do it, there are n number of difficulties. We have seen that personally. We have had problems, and if I had showed you this in this research work also, there's a small miscommunication which I wanted to represent you once again, like this one. If you can see here, R square value is above 0.9. Adjacent R square value is also good agreement with R square. But the problem is the predicted. It is 0.48. So this way, what we thought is the readings what you have done is good enough. But the regression equation what was there is not in good agreements. So you can't use that regression equation. He may have done the experimentation good or selecting the factors, and this thing is fine, but the model what you get is not in good agreement. So this kind of problems we face usually when we do it on some, and 2 hours is not actually a sufficient time for grasping the thing. So the thing is like, yes, we need to spend some time, use some research papers, just explore yourselves with the basics, and then fix up your design and go ahead. So with this, I would hand over the session to our coordinator, sir, and I thanks all the participants for showing such a love and so communicative. Actually, I should thank you actually for being such communicative, because what I say is, it's not, if you're raising any question on this platform, it is not only that I am clearing your doubt. It's also that the other participants, those who are hesitating or those who will come across in the near future with that kind of problems, will have this idea in mind, and they take precautions. So always we should entertain, or we should be communicative, so that it's not, it is not addressing your only doubt, but it is helping the other participants also. So with this, I would like, this is my last session for this STTP, and with this, I would like to, I am saying that this session, what I have done now, because the first 2 sessions, we couldn't have much of the communication, but this session, what I have done now, has given me an huge satisfaction, being as a researcher, or the way, it means communicating the things what I am having and the interaction what we had. So I'm very happy with the today's session, how it went. And I thank the coordinator for giving me this opportunity, and our society, Sri Vishnu Educational Society, through which we got this opportunity. And I especially thank the coordinator who has fitted me into this STTP. I say that because he wanted all these basics and all these things to come out, and he has forcefully fitted me. Actually, if I say this was myself, means he has fitted me forcefully into this STTP, and I hope that I have justified the tag for that. And thank you, Varun sir, for giving me this opportunity, and thank you, participants, for showing the love and affection and being interactive. Thank you, one and all.
Thank you, sir. So, yes, sir. So, it was very informative, and at the same time, we had a very good discussion. Actually, that's what is needed. And as a resource persons, every resource person whom I have interacted, they all mentioned that since you are asking questions, it was very encouraging, and that's what even Sandeep has felt. And we both thought of doing it with physical sessions, and then trying to incorporate few of the exercises that we even encountered, and then try to demonstrate everything in the afternoon sessions and all. But since it's online, we were also doubtful how to present it, but I think it went very well. And I am again thankful to Dr. Sandeep, because when I tried to fit the sessions in a sequential manner, I was having some blanks, and those blanks I wanted it to be filled by very basics, and that blanks I thought I'll ask Dr. Sandeep, Salma ma'am, and then even Kumar sir. So I think this is the first half that we have done successfully. The second half is full of case studies, full of new concepts, I could say. Yesterday, even when I was interacting, even the other person was mentioning about some case studies and something in advanced levels, like some various areas of interest. So today's afternoon session is going to be on Taguchi, which is going to be by Dr. Davidson sir. He is from Associate Professor, Mechanical Engineering Department from NIT Warangal. So I hope you will join on time, 1:30 sharp, because sir will be there 1:30 sharp. So without much delay, we'll join back again 1:30. Thank you all. Thank you very much. I'll share the feedback through WhatsApp group. Please do fill that feedback form and join us for 1:30 afternoon session. Thank you. Signing off.